Hi, we are Group 4. Today our topic is 5.1 Fundamentals of Waves. What is waves? An oscillating or vibrating motion in which a point or body moves back and forth along a line about a fixed central point produces waves. Let us look at activity 5.1. Activity A. Oscillation of iron bob at the end of a spring. After observing this activity, we can know that the oscillation of an iron bob on the water surface produces water waves. For the second activity, activity B, vibration of a tuning fork. The observation is the vibration of a tuning fork in the air produces sound waves. Through activity 5.1, we can conclude that waves can be produced by an oscillating or a vibrating system. Oscillation and vibration are repetitive motions about the equilibrium position in a closed path. Next, let us look at activity 5.2. Do waves transfer energy without transferring matter? Through activity 5.2, we can conclude that waves are produced when a medium vibrates at a fixed position. Propagation of the waves transfers energy from one place to another without transferring the matter of the medium. Movement of waves from NA to NB transfers energy from A to B. The ribbon only vibrates about in a fixed position. The ribbon does not move in the direction in which the energy is transferred by the waves. Now we will talk about types of waves. Figure 5.5 shows the shape of the slinky spring at 5 consecutive instances after NA has been moved as in activity 5.2. The shape of the slinky spring as waves propagate through it is known as wave profile. Extra info: a wave profile is a set view of a wave and is used to show wave features including crest, fray, wave height, and wavelength. Waves can be classified from the aspect of propagation of the wave profile. The wave profile in figure 5.5 propagates with time along the direction of propagation of the wave. This wave is known as progressive wave. Extra info: a progressive wave is a term given to a wave that travels from a specific point A in the medium to another point B. In simple terms, a wave that continuously travels in the medium in the same direction minus the changes. This graph shows an example of a progressive wave produced by the vibration on the surface of the water. A wave profile propagates outwards in all directions. And the second graph shows the animation of transverse waves and longitudinal waves. Wave produced along a guitar string being plucked is an example of a stationary wave. A stationary wave is a wave where the profile of the wave does not propagate with time. Stationary waves are also produced by musical instruments such as ukulele, flute, and drum when these instruments are played. This graph shows a profile of a stationary wave. Extra info: stationary wave is produced when two identical progressive waves moving in opposite direction collide with one another. Waves can also be classified as mechanical waves or electromagnetic waves. Mechanical waves requires a medium to transfer energy from one point to another and made up of vibrating particles of a medium. For examples, water waves, sound waves, and seismic wave on the surface of the earth. Electromagnetic wave does not require a medium to transfer energy. It is made up of oscillating electric and magnetic fields perpendicular to one another. For examples, radio waves, light waves, and gamma rays.
Comparison between transverse wave and longitudinal wave. Similarities of transverse wave and longitudinal wave. Both produced by vibration or oscillation. Both transfer energy without transferring matter, and both propagated by vibration or oscillation of the particles of the medium. Next, the differences between transverse wave and longitudinal wave. Transverse wave is a wave in which the vibration of particles in the medium is at right angle perpendicular to the direction of the propagations of the wave, and the transverse wave is made up of consecutive crest and trough. And you can see the direction of vibration of the particle is traveling up and down, but the wave energy is still moved horizontally. The example of transverse wave are radio wave, light waves, and water waves. Next, longitudinal wave. Longitudinal wave is a wave in which the vibration of particles in the medium is along, parallel to the direction of the propagation of the wave. Longitudinal wave is made up of consecutive compression, compressed regions, and rarefactions, stretched regions. The example of longitudinal wave is sound wave. So from here you can see it. The wave energy is moved horizontally back and forward.
Characteristics of wave. Figure 5.12 shows the profile of a water in a pond. Change in wave profile. When water wave propagate towards a shallower region, the speed of the water wave decreases and the crack gets closer. As the water wave energy remains unchanged, the height of the wave increases. Question: what changes can you observe as the wave propagates across the water surface? Tips: to answer this question, you need to know the definition of terms related to wave. The table shows the term and its definition. Amplitude is the maximum displacement of a particle from its equilibrium position. Period is the time taken by a particle to make one complete oscillation or by a source to produce one complete cycle of wave. Frequency is number of complete oscillations made by a particle or number of cycles of wave produced by a source in 1 second. Wavelength is the distance between two consecutive points in phase. Wave speed is the distance traveled per second by a wave profile. Info file. Equilibrium position is the original position of the particle before a system oscillates. For wave of frequency, f equal to 1 over t. Displacement is the distance of a particle from the equilibrium position. This video shows the introduction of wave. You can copy the link or scan the QR code to watch the video. Figure 5.13 illustrates the amplitude, points in phase and wavelength of a transverse wave. Identify several other distances that are equal to one wavelength. Figure 5.14 shows the points in phase a longitudinal wave. Figure 5.15 shows the profile of a transverse wave at one distance and after a period t of the wave. In time, t equal to t, the wave profile propagates through the same distance as the wavelength lambda. From the equation, speed equal to distance traveled by a wave profile over time. Speed of wave v equal to lambda over t equal to 1 over t multiply lambda. Frequency of wave f equal to 1 over t. Therefore, speed of wave v equal to f multiply lambda.
Sketch and interpret wave graphs. Particles along the wave oscillate up and down about the equilibrium position. Two types of graphs can be drawn to show the variation of the displacement of wave particles, which are graph of displacement against time and graph of displacement against distance. Activity 5.5. Method of sketching a graph of displacement against time. Method of sketching a graph of displacement against distance. This is the graph of displacement against time. It obtains amplitude, period, and frequency. And this is the graph of displacement against distance. It obtains amplitude and wavelength. Smart info. Speed of a wave v equal to f lambda can be calculated from the information obtained from a graph of displacement against time and a graph of displacement against distance. Determining wavelength, frequency, and wave speed. A ripple tank is used in the laboratory to study water waves. It consists of a water tank made from perspex or glass, ripple generator, digital xenon stroboscope, mirror, glass screen, and dipper. This is the back view and side view of a ripple tank. It has digital xenon stroboscope, ripple generator, dipper, water tank, glass screen, mirror, and power source and control unit. There are two types of dippers that can be used. The first one is plane dipper. Plane dipole produce plane waves. The second one is spherical dipole. Spherical dipole produce circular waves. Thank you.